Good morning to everyone. My name is Arvind from Srinivas Ramanjan Institute of Technology, second year CSC. Today's my topic is synchronous upcounter 2-bit, 3-bit. Subject name is Digital Logic and Computer Organization. First of all, introduction to synchronous upcounter. Synchronous upcounters are digital devices used in counting applications. They increment their count based on a clock signal, ensuring all bits change simultaneously. This design minimizes timing issues, making synchronous counters more reliable than asynchronous. Synchronous counter explained in part 1. 3-bit counter. The basics of 2-bit synchronous up counter. A 2-bit synchronous up counter can count from 0 to 3, representing binary values 0, 0 to 1, 1. It consists of 2 flip-flops, each representing 1 bit of the count. The counter increments on the rising edge of the clock pulse, with both bits toggling based on specific conditions. A 2-bit counter operation. The first flip-flop toggles its state with each clock pulse, representing the least significant bit LSB. The second flip-flop toggles when the first flip-flop transition from the high to low, representing the most significant bit MSB. The cascading effects allows the counter to correctly represent the binary increments. The truth table for 2-bit up counter. The truth table outlines the current state and the next state for each clock pulse. It shows the transitions from 0, 0 to 0, 1, 1, 0 and finally 1, 1 before wrapping back to 0, 0. Understanding the truth table is essential for designing and troubleshooting the counter circuit. The truth table of a circuit that has 3 inputs and 2 outputs is shown in the table 8 below. We are given ABC inputs and output is sum and Cout. Find a simplified Boolean equation for the sum and Cout signal. Show your workout. Draw the circuit of sum out signals. Circuit diagram of 2-bit synchronous up counter. The circuit diagram includes 2 D flip-flops connected to a common clock signal. Logic gates are used to control the toggling of the second flip-flop based on the out of the first. This arrangement ensures that both flip-flops are synchronized with the clock signal. The logic diagram for 2-bit up counter. Introduction to 3-bit synchronous up counter. A 3-bit synchronous up counter can count from 0 to 7, represented in binary from 0, 0, 0 to 1, 1, 1. It consists of 3 flip-flops, each contributing 1 bit to total count. The design is similar to the 2-bit counter but includes additional complexity due to 3rd bit. Here the diagram shows the logic clock from input to output. 3-bit counter operation. In a 3-bit counter, the first flip-flop toggles with each clock pulse serving as the LSB. The second flip-flop toggles when the first flip-flop transitions from high to low, while the third toggles based on the states of the first 2. This cascading toggle mechanism allows accurate counting up to 7. Here is diagram 3-bit ripple counter. Assume Q0 equals to Q1 equals to Q2 equals to 0 at T equals to 0 and assume each T flip-flop as a delay of 1 ns for the clock input to the Q output. Fill the Q0, Q1 and Q2 of the timing diagram. The flip-flop Q1 will be triggered when Q0 changes from 0 to 1. The flip-flop Q2 will be triggered when Q1 changes from 0 to 1. Here the clock shows the flip-flops. The truth table for 3-bit up counter. The truth table for 3-bit up counter illustrates all possible states and transitions. It includes binary count from 00 to 111, showing how each state leads the next with each clock pulse. This table is crucial for understanding how to counter the increments of debugging purposes. In the previous state Q3, Q2, Q1 and Q1, Q2, Q3, the in previous state Q1 0, Q2 0 and Q3 also 0, and next state the Q1 becomes 1 and Q2, Q3 also 1. Here the 3T, T3, T2, T1 are also 1. It changes from previous state to next state. Circuit diagram of 3-bit synchronous up counter. A 3-bit synchronous up counter circuit diagram includes 3D flip-flops connected to a common clock signal. Logic gates manage the toggling of the second and third flip-flop based on the outputs of the preceding flip-flops. This setup ensures synchronization and correct counting behavior across all bits. Applications and conclusion. Synchronous up counters are widely used in digital electronics for counting applications such as timers and frequency dividers. Their predictable behavior and reduced timing issues make them essential in synchronous system. Understanding both 2-bit and 3-bit designs provides a foundation for more complex digital circuits. Synchronous counter explained part 1, 3-bit up counter. Here the clock and the output. And thank you.